Now we're going to practice using that rule, the exponent rule, when you have an outer exponent. So if you remember, if you have a, b, and that's in parentheses to like some power, then it's equal to a to the m and b to the m. So each base gets that exponent. And so you have to decide, well, what are the bases? So you have 32 here in the parentheses. 32 is going to get that exponent 3/5. And then you have x to the 1/3, and that's also going to get the exponent of 3/5. Okay, so now I have to do some simplifying. So 32 to the 3/5, I'm going to think of that in radical notation. So I'm going to think the 5th root of 32 to the power of 3. Okay, so that's using it from the rational exponent notation to the radical notation. Now the x, I'm going to multiply those, so it's going to be 1/3 times 3/5. Okay, so now I need to do some simplifying. I know what the 5th root of 32 is. We don't have a lot of 5th roots, but the 5th root of 32 is 2. Now if you're like, well, I didn't know that, you go over to the side and you break it down into prime factors. 4 times 8, and then 4 is 2 times 2, and 8 is 2 times 2 times 2. So you have a group of 5. And so you might get a number that you're not familiar with. So that's what I recommend. Just break it down into prime factors. Okay, so that's the 5th root of 32 is 2, but we still have to cube it. And then we're going to have x to the, now in multiplying those fractions, those 3's cancel, so we can just go to the 1/5. And then they don't want it to say 2 to the 3rd. They want you to multiply that out. So 8x to the 1/5. Generally, we multiply these out if it's a fairly small number. If it's like gigantic, like 7 to the 23rd power, we don't multiply it out. But a lot of times, they're going to want you to multiply them out. Okay, I'm doing something different here. Let's do the next problem. Okay, so now on this one, in parentheses, we have an x and we have a y as the bases. So it's going to be it's going to be x to the 3/4 times 2/3, and then it's going to be y to the 1/2 times 2/3. So I'm bringing in that outer exponent and I'm multiplying it times the inner exponents. Okay, so here the 3's cancel and 2 goes into 4 twice. So you get x to the 1/2. You could multiply and get 6/12 and then reduce it to 1/2. That'd be fine. And then here you're going to have y to the 1/3 because those 2's are going to cancel. And that one's done. Okay. Now if you were thinking, oh, I could do more, I could add those exponents. No, you can't add those exponents because the bases are different. This one's an x and this one's a y. You only get to add the exponents if the bases are the same. Okay? So when you're multiplying. Oh, that was it.